Hey guys, so today we're starting the last section in chapter 5, which is 5.5, normal approximations to binomial distributions. So normal being the normal curve. So we are on page 275, and what we're going to look at is in the middle of page 275, we see a little box that says normal approximation to a binomial distribution. So this is the guideline as to whether or not we can even use a normal approximation. Okay, we have to have n times p be greater than or equal to 5, and n times q has to be greater than or equal to 5 as well. And n is the number of data entries you've got, the sample number. P is the probability of the favorable outcome, and Q is the probability of the unfavorable outcome, which, if you recall, is what a binomial distribution does, okay? It approximates the P and the Q, the favorable outcomes versus the unfavorable outcomes. So if n times p is greater than or equal to 5, as is n times q, your mean can then be found, which is n times p, and then the standard deviation can be found, which is the square root of n times p times q. So if you look at the bottom of page 275, you can see that as the value of n gets bigger and bigger in those graphs, the bigger the n value, the more the graph represents the normal curve, our bell curve, normal distribution, okay? So what we're going to do is start out in example 1. We're going to do the try it yourself, okay? So it says, in a survey of adults in the United States, 34% said they have seen a person using a mobile device walk in front of a moving vehicle without looking. You randomly select 100 adults and ask them whether they have seen a person using a mobile device walk in front of a moving vehicle without looking. So what we're doing is first identifying N, P, and Q. Well, you randomly select 100 people, so N is equal to 100. And the percent that say they did see a person walk in front of a car without looking is 0.34. So Q is 1 minus 0.34, which is going to be 0.66. That's our NPQ. Now, if we can use a normal distribution for this, n times p has to be greater than 5. Well, n times p is 34, and n times q also has to be greater than 5, and n times q is 66. So the normal distribution to this binomial is possible because those two values are greater than 5. So we can find the mean, which is the same thing as n times p, and then we can find the standard deviation, which is going to be 100 n times p, let's just do parentheses, times q. And that would give us a standard deviation of 4.7. Okay? And eventually we are going to use that information to find the area or the probability of certain things happening. Okay? But what we're seeing in example 2 at the top of page 277 is we need to decide whether or not we are including values, okay? That's what continuity correction is. So what we're going to do is look at try it yourself too, okay? And then we'll talk about the bottom of page 270 a bit. So in try it yourself too, it says find the probability of getting between 57 and 83. Okay, so what we're wanting to do here is write the probability that we are going to be putting into our calculator as our bounds. Okay, now the probability of getting between 57 and 83 means we're including the 57 and we are also including the 83. So our adjustment is by increments of 0.5. So if we're including 57, we need to start at 56.5. And if we're including 83, we need to end at 83.5. Okay, because that includes the 57 and it includes the 83 to go up by 0.5 or down by 0.5. Okay, now look at the try it yourself number 2. The probability of getting at most 54. So we need to determine whether or not 54 is included. At most 54. So 54 is included, and so is every number less than that. So you can have 54, you can have less than 54, but you can't have more than 54. So if you're including the 54, the probability would be x is less than 54.5. And that 54.5 is going to be a bound, upper or lower, that we use in our normal CDF program on our calculator. Okay? So if we're looking at the bottom of page 277, you see the words exactly, at most, fewer than, at least, and more than. Okay, so let's look at exactly. Okay, so say we are exactly, I'm going to pick just some random bound, exactly 50. If we are at exactly 50, the probability would have to include just below 50 by 0.5 and just above 50 by 0.5, okay? Because the number that falls exactly in between those two, 49.5 and 50.5, is 50, exactly. Now, if we were at most 50, okay, so at most 50, we need to first decide, are we including 50? Yes, we are. We can have 50, we can have less than 50, but we can't have more than 50. So that probability would look like x is less than 50.5 because we are including the 50. And then, of course, all the numbers less than that. Now, the next one is fewer than. Okay, so if we are looking at fewer than 50, we are not including the 50. So the highest we can go is 49.5. Okay. Then if we've got at least 50, we are including 50 and of course everything greater than that. So if we're including the 50 and everything greater than that, we need to make sure that by including the 50, we start at 49.5. Because if we started at 50.5, we would not be including the 50. 50.5 is over 50. That would be including 51. So if we're including a number, we need to be 0.5 less than that number, okay? And then more than 50, we are not including the 50. We are not including the 50. So the probability, as far as our bounds go, are 50.5. X is greater than 50.5. So the thing that we need to do is determine whether or not we are including that number or not. That is the key here. Okay? So, looking at the next page, okay? In order to determine whether or not we can use a normal distribution to approximate binomial probabilities, the first thing we're going to do is find the NP, the NQ, and they have to be greater than or equal to 5. If that's true, then we can continue on with the process here, okay? So we're going to do, under example 3, we are going to do the try it yourself 3, and then we're going to use that to solve and find probability. So in a survey of adults in the United States, 34% said they have seen a person using a mobile device. So that is our P. Very similar to, I think this is the exact wording of what we had in Try It Yourself 1. So if P is 0.34, Q is 0.66, okay? And it says you randomly select 100 adults. So N is equal to 100, okay? Now the question asks us, what is the probability that more than 30 respond yes? More than 30. So we need to decide, are we including the 30 or not? Okay, so if it's more than 30, we are not including the 30. So the probability that we are going to be looking for is that X is greater than 30.5, because 30.5 being bigger than 30 does not include the 30. Okay, so first thing we have to do is determine whether or not we can use the normal approximation to this binomial distribution. So we have to find N times P and N times Q. Okay, N times P is 34, N times Q is 66. So yes, we can use a normal approximation to this binomial distribution, okay? And because of that, we know that the mean is 34, and the standard deviation multiplying N times P times Q gives us a standard deviation of 4.7. Put it in your calculator just to make sure. The square root of 100 times 0.34 times 0.66. That is your standard deviation. Now we're looking for the probability that X is greater than 30.5. Okay, so here we can use our normal CDF. Okay, so if we're looking for values great, or the area that is greater than 30.5, that is our lower bound, 30.5. Our upper bound is some 10,000, 100,000, whatever, okay? Then our mean comes next, and then our standard deviation comes after that, all right? So the probability, or the area to the right of 30.5 on a normal distribution curve is 0.7718. Okay? Easy stuff. Easy stuff. Moving on to try it yourself 4. Okay, same idea. So in example 4, it says 58% of adults say they never wear a helmet when riding a bike. So that is our p-value. Okay, 58%. That means that Q is going to be 0.42. Okay, that is the information that we're looking at, and we have N equals 200 adults. Okay, that is the information from example 4. Now we're going to apply that into try it yourself 4. Okay, so in try it yourself 4, it says, what is the probability that at most 100 adults will say they never wear a helmet when riding a bicycle? So at most 100. So are we including the 100? Yes, we are. We are including the 100. So what we're looking for is the probability of, now at most is you can have 100, you can have less than 100, but you can't have more than 100. So the probability, including the 100 and everything less than that, is 100.5. So we're looking for the area to the left of 100.5 on the normal distribution curve. But first we have to be able to see if N times P and N times Q are greater than 5. Well, N times P is 200 times 0.58, which is 116, and N times Q, 200 times 0.42 is 84. So yes, we can use a normal distribution to this binomial, or a normal approximation to the binomial distribution. And the mean is the N times P, and the standard deviation is going to be the square root of, let's just write it all out, 200 times 0.58 times 0.42 to get that your standard deviation is 7.0, rounded. Okay, now we can find the area to the left of 100.5 on the normal distribution curve using the raw scores. Okay, so if we're less than 100.5, we're starting at negative 10,000 or negative 100,000. It doesn't matter. Stopping at the upper bound of 100.5, then our mean, then our standard deviation. And the area to the left of 100.5 is 0.0134. Okay, and that is obviously an unusual event. Okay, easy stuff, easy stuff. Okay, so example 5 is exactly the same thing. Okay, one more example. It says the study in example 5 found that, so whatever happened in example 5, we've got all the information we need in try it yourself. 32% of all men in the United States 50 and older have arthritis. So P is that 32%, so 0.32. That means that Q is 0.68. Now it looks like the number that we are randomly selecting is 75 men, okay? So we need to know what is the probability that exactly 15 will say they have arthritis, okay? So exactly 15. So if we can use a normal approximation, we have to figure out what the area is. Well, we need to include 15, exactly 15. So we need to start at 14.5 and end at 15.5 to include 15. So we need to see if N times P and N times Q are greater than 5. Okay, N times P is 24, 75 times 0.32, and NQ is 51. 75 times 0.68. So obviously, the normal approximation can be used. And our mean is 24, same as NP. And the standard deviation is to multiply all of those together, which gives us a standard deviation value of 4.04. Please check that on your calculator, okay? Now, because we are between 14.5 and 15.5, those are the upper and lower bounds that we enter into our calculator, okay? 14.5, comma, 15.5, comma, the mean, 24, and then the standard deviation, 4.04, to get approximately 0.0083. Okay? Very, very simple. So what you will be doing for your homework on pages 281 to 282 are numbers 18 to 30 evens. Very simple stuff. Lovely way to finish off a chapter.